Okay, so this evening we are going to be looking at something called Newton's laws of motion. Newton's laws of motion are very, very important because they give us a connection between what we have looked at so far in terms of displacement, velocity, whether it's initial velocity, final velocity, acceleration, and something called force. Okay. So Newton's laws of motion show you what causes the acceleration, what causes an object to accelerate. That's where Newton's laws of motion, that's what Newton's laws of motion try to explain. They try to explain to you when you're going to have acceleration and when you cannot have acceleration. Okay, so basically that's what Newton's laws of motion are trying to do. They give you a connection between something called force, which is going to connect you to the mass of the object, and the acceleration. So, during the course of this lecture, we'll seek to understand what mass is. When we refer to something mass, what are we trying to talk about? Then also, we're going to introduce you to Newton's laws of motion, the first law of motion, the second law of motion, and the third law of motion, and you should be able to apply these three laws of motion. Then, of course, we're going to introduce you to a very important relationship, which is the famous F is equals to ma. Now, as simple as this is, F is equals to ma, we are going to explain to you what the F stands for. Yes, it looks like force, but it is actually not just any force. It is a special kind of force called resultant force. Now, resultant should ring bells in your head because when we looked at vectors, we were adding or subtracting vectors and we're calling the result the resultant vector. So in the case of force here, what happens is that it turns out that when you have an object which is moving, it turns out that that object experiences a bunch of forces. There are a number of forces acting on this object. So you are actually required to add these forces so that you can come up with a resultant. And that is the F we are talking about here. This F is not just one force. It is something called a resultant. This resultant force is what gives you the connection between the mass of an object and the acceleration. That's what Newton's second law of motion says. F is equals to ma gives you the connection between a force, which is called a resultant force, the mass of the object, and the acceleration which that particular object is going to undergo. Then, of course, we're going to introduce you to a bunch of forces. For example, as long as you have got mass and you live on this earth, as long as you've got mass and you live on this earth, you experience the pull of gravity. So the earth is always pulling on you. So as long as you've got mass, then there is a force which is acting on you, which is known as the weight. So we'll show you how this weight is worked out, how you work out the weight. Basically, most people already know how to do this. It's just the mass of the object multiplied by the acceleration due to gravity that gives you the weight of that particular object. So we'll show you how to work out the weight and a bunch of other forces. So basically that's what the lesson looks like. So we want to introduce you to mass, we want to introduce you to Newton's laws of motion, then also a detailed discussion of the resultant force, how do you find the resultant force, and other things, other types of forces which are going to introduce you to. Now, in terms of Newton's laws of motion, we are also interested in the mass of an object. And this mass of an object is basically a measure of the inertia of that object. Inertia is the tendency of an object to remain at rest or of an object to move with constant velocity. So depending on how much mass an object has, if the mass is large, that particular object will tend to remain at rest. If the mass is also large, it is going to be very difficult for you to try to stop this object or to change its velocity. Usually, large objects tend to stay at rest. If they are moving, they tend to move with unchanged velocity. So this is what is called inertia. So the more an object resists change of state, if it's at rest, then you try to make it move, but it resists. The more it resists, the more mass it has. So basically that's what mass is in terms of physics. It is a measure of the inertia of an object, and inertia in turn is basically the tendency of an object to remain at rest or an object to continue with constant unchanged velocity. So there is no acceleration basically there. Okay. The mass is measured in kgs, and you have already seen at the beginning of the course what a kg is, and you can go back if you have forgotten. Okay. Now, the next thing we want to talk about is force and what force does. Okay. Now, if there is a force acting on a particular object, what that particular force will tend to do is that it will change the velocity of the object. So if there is a force acting on an object, that force tends to change the velocity of an object. Either it will reduce the velocity of an object or it will increase the velocity of an object. So here, our language of force is basically that which causes the velocity of an object to change. So if the velocity of an object changes, then we know that there is a force acting on this particular object. Okay? That is if it's just one force. If there's one force acting on an object, that force is going to cause the velocity of this particular object to change. However, as we are going to show during the course of the lecture, coming lectures, an object can have more than one force acting on it. So at the end of the day, when you add up all these forces acting on a particular object, these forces can cause the velocity of an object to change, or they can cause the velocity of an object to remain the same. Okay. Newton's laws of motion, especially the second law, is going to show you that if you have a bunch of forces acting on an object, then you add them to get a resultant force. If the resultant force is equals to 0, then the acceleration which the body experiences is going to be equals to 0. So acceleration actually depends, according to Newton's second law of motion, acceleration depends on the existence of a resultant force. So if you add the forces acting on a body, then those forces, if you add them, if they don't give you 0, so they have to be positive or negative. If they give you, they have a non-zero magnitude, then there's going to be acceleration. If the forces, the resultant force is positive, then there's going to be a positive acceleration, which is going to result in the velocity of an object increasing. If, on the other hand, the resultant force is negative, then there's going to be an acceleration, which is going to be negative, and as we know, a negative acceleration causes an object to slow down and eventually come to a stop. If, on the other hand, there is no resultant force after you add all your forces together acting on an object, the resultant force is 0. In that particular case, the acceleration is going to be equals to 0. If the acceleration is equals to 0, one of two things can happen. Either that particular object will remain at rest, or that particular object is going to move with constant velocity. So basically, yeah, so this is what we mean by force. Force causes the velocity of an object to change. Okay, so Newton's first law of motion, what does it say? This is what it says, and I'll read it out. An object at rest will remain at rest. So an object at rest will remain at rest. An object in motion will continue in motion with constant velocity until it is acted upon by an external force. Force is the changer of motion. So if there is no force acting on an object, Newton's first law of motion says that an object will remain at rest if there is no force acting on it, or an object will continue to move with constant velocity if there is no external force acting on that particular object. So in this case, force is what causes a change in motion. Whether the velocity of an object increases or the velocity of an object reduces, the increase in velocity or the reduction in the velocity of an object is caused by a force. Are we clear? The increase in the velocity of an object or the decrease in the velocity, the increase or the decrease in the velocity of an object is caused by a force. So if there is no external force acting on an object, that particular object, if you leave a drum of water outside, you should be able to find it the following morning if someone has not applied the force on it. Or if something is moving with constant velocity, it should continue to move with constant velocity as long as there is no force acting on it. Yes, we always record the lectures and post them on YouTube, and also the links are posted on Moodle. Okay, so that's Newton's first law of motion. It talks about the need for you to have an external force. If there is no external force, then an object moves with constant velocity, or an object will remain at rest. What we are interested in is the motion to change. We want the velocity to change. Otherwise, if the velocity does not change, then there's nothing interesting happening. If an object is at rest, we know what its velocity is. It's 0 meters per second. If we come back after 1 hour, since the object is at rest, the velocity is still 0 meters per second. If you come back the following day, the velocity will still be the same. So there's nothing interesting happening there. If an object is moving with constant velocity, again, you know what the velocity is. If it's moving at 20 meters per second, it will always move at 20 meters per second because it's moving with constant velocity. There is nothing interesting happening. We want things to be interesting. Therefore, we need a force to change the velocity, whether to increase it or to reduce it. So if the velocity of an object increases, then you have got acceleration. If the velocity of an object reduces, you also have acceleration. What is causing the acceleration is a force. You need to have force for the velocity to change. That's what Newton's first law of motion is trying to say. Okay. Then we move on to Newton's second law of motion. Okay. Now, Newton's second law of motion assumes that a force is present. Now, if a force is present, how much change or how much acceleration is this force going to cause? So, if the resultant or net force F acting on an object of mass m is not zero, so if the resultant force is not zero, it means that this resultant force is present. The resultant force is a vector. It can be a positive force or it can be a negative force. Because for you to get a resultant, you need to add forces together. Okay? So if the resultant force F acting on an object of mass m is not zero, the object accelerates in the direction of the force. So the first thing we're being told here is, if you have a resultant force present, okay, then the acceleration is going to be in the same direction as the force. The acceleration A is proportional to the force F, which is the resultant force, and inversely proportional to the mass of the object M. This force we are talking about is something called a resultant force. So according to Newton's second law of motion, if you have a resultant force which is not equals to 0, so it can be positive or negative, then the acceleration is going to be the same direction as the force. In addition to that, the acceleration you will produce will be proportional to the force. So the more resultant force you have, the greater the acceleration, or the less resultant force you have, the less the acceleration, and it's going to be inversely proportional to the mass. So if the mass is large, the acceleration will be less. If the mass is small, the acceleration will be greater. And this is what we mean. The acceleration A proportional to the mass F is proportional to the resultant force F and inversely proportional to the mass. If you rewrite this equation here, A equals to F divided by M. If you rewrite this equation, you end up with this much better equation. F is equals to MA. This is Newton's second law of motion, equation number 1. This equation tells you that for you to have an acceleration A, you need to have a force, F, the resultant force. You can have an object which has got mass M, but that particular object can be at rest. If an object is at rest, then the acceleration is equal to 0. Or you can have this particular object, and this object is moving with constant velocity. So if the velocity of the object is not changing, then the acceleration of that particular object is equal to 0. Okay. So mass has got an effect on the acceleration, okay? But what causes acceleration is the force, the existence of something called resultant force. You get a resultant force by adding forces acting on this particular object. So from the word go, I want you to be aware that what causes an object to accelerate is not one force. Sometimes you can have one force, but it is something called resultant force. And this resultant force, you get it by adding forces acting on the object. Okay. The other thing you should be aware of is that the acceleration is always in the same direction as the resultant force. The reason is very simple here. If you look at M, which is the mass of the object, the mass of an object is a scalar quantity. Okay. Then you look at the acceleration is a vector quantity. So you are multiplying a scalar, which is a mass, times a vector, which is acceleration. If you multiply a scalar times a vector, what you get is a vector. So this resultant force is a vector. The way this equation has been written, F is equals to ma, you might be confused to think that the acceleration A is causing the force. No, it is the other way around. The acceleration depends on the existence of a resultant force. If resultant force is not equal to 0, then you have acceleration. If resultant force is equal to 0, meaning that the resultant force is not present, then the acceleration is equal to 0. So it is the resultant force which causes the acceleration, not the acceleration causing the resultant force. Are we clear on what Newton's second law of motion is saying about the resultant force? You need to have a resultant force for you to have an acceleration. Are we clear?
Yes, sir, we are clear.
Okay. The next thing is when you're trying to work out resultant forces, you are interested in forces in a particular direction. For example, if you might have forces acting along the x-axis in the horizontal, you also might have forces acting in the y-axis. So what you do is you rewrite this equation F is equals to ma in terms of directions. So here you have this whole thing here. This is a summation. So you add all the forces acting along the x-axis. That's what this is trying to tell you. The sum of the forces acting along the x-axis. So you add, you identify which forces are acting on this particular object. And out of these forces acting on this object, which ones are acting along the x-axis. So you need to identify which force is acting along the x-axis, then you add these forces. Forces are vectors, so you need to choose which direction along the x-axis is going to be the positive x-axis, which one is going to be the negative x-axis. So all forces pointing in the positive, what you have chosen to be the positive x-axis, those are going to be positive forces. All forces pointing along the negative x-axis, those are going to be negative forces. So you add positive and negative forces. Then when you add them, you end up with one force, which is what is called the resultant force. So when you add your positive forces and your negative forces, that resultant you're trying to get might be positive, it might be zero, or it might be negative. It can be one of three things. A resultant force can be negative, a resultant force can be zero, a resultant force can be positive. If your resultant force is positive, it means that the acceleration which is going to be caused by this positive force is going to be negative, is going to be positive. So if the acceleration is positive, then your object is going to move faster and faster. The velocity of that particular mass will increase. That's what it means to have a positive resultant force. A positive resultant force will cause a positive acceleration. If an object is experiencing a positive acceleration, it means that the velocity of that object will increase. Are we clear? On the other hand, if the resultant force is equals to zero, meaning that there is no resultant force present, yes, the forces are there, but when you add these forces, what you get as the sum of these forces is a zero. It means that there is no acceleration. The acceleration along that x-axis will be equals to zero. So this object will either remain at rest or it will move with constant velocity. When an object is moving with constant velocity, it means that that particular object has got no acceleration. On the other hand, if the acceleration, the resultant force is negative, when you add your vectors along the x-axis, the positive vectors and the negative vectors, when you add them, then you get a negative resultant force. Okay? In that particular case, it means that your acceleration ax is going to be negative. A negative acceleration results in your mass undergoing a slowdown. So there is going to be a reduction in the velocity of that particular object. If there is a reduction in the velocity of that particular object, eventually that particular object would definitely come to a stop. So this is how you write Newton's second law of motion along the x-axis. So you identify the forces acting along the x-axis, then you add them, you get your resultant along the x-axis. This resultant along the x-axis will help you, using this equation 2, get the acceleration along the x-axis. So you get the x component of the acceleration, ax. So ax, you just have to divide the resultant by the mass. So once you have the resultant, then you divide the resultant by this mass, you get yourself ax. Similarly, you can do the same thing along the y-axis. You identify which forces are acting along the y-axis on this particular object. Since you are talking about vectors and adding vectors, you need to identify which direction is going to be positive, which one is going to be negative. Usually people choose the positive y-axis to be the positive direction. So all the forces pointing up will be treated as positive, and all forces pointing down will be treated as negative. Then you add them. When you add them again, you end up with a resultant force acting along the y-axis. If this resultant force is positive, there's going to be an increase in acceleration along the y-axis. If the resultant force is 0, there will be no increase in velocity. If the resultant force is negative, there's going to be a reduction in the velocity. Again, you can find out how much the acceleration is along the y-axis, AY, by dividing the resultant force along the y-axis by the mass of the object. Once you know how much is the acceleration along the x-axis and how much is the acceleration along the y-axis, you can find out what the acceleration is, because the acceleration along the x-axis and the acceleration along the y-axis are just components of acceleration, and the acceleration is a vector. So the components ay and ax are giving you how much is the acceleration along the x-axis and how much is the acceleration along the y-axis. Once you know those two, then you can find what is the acceleration. A is equal to the square root of ax squared plus ay squared. We have done this. This formula should be familiar to you when you are looking at vectors and how to find the magnitude of a vector. So this is a very, very important result here. Statements, these three equations, very, very important. Equation number 1 tells you that for you to have acceleration, for an object of mass m to have acceleration, you need a resultant force, F. Equation number 2 shows you how you find the resultant forces. You need to work out the resultant force along the x-axis by adding all the forces acting along the x-axis. So you choose direction, which one is the positive x-axis, which one is the negative x-axis. All the forces pointing in the positive x-axis, you treat them as positive forces. All the forces pointing in the negative x-axis, you treat them as negative forces. Then you add them. You find this resultant force. This resultant force divided by the mass of the object gives you the acceleration along the x-axis. You do a similar thing along the y-axis. All forces pointing in the positive y-axis, you treat them as positive. All forces pointing in the negative y-axis, you treat them as negative. Then you add those forces. When you add them, then you end up with a resultant. With that resultant, if you divide by the mass, then you get your acceleration in the y. This acceleration in the y and the x, if you do this, you end up with what the overall acceleration is. You will not, as you're going to find out, deal with a lot of forces. You just deal with one or two forces, but to ask you, you need to find the resultant force. Okay. So that's about Newton's second law of motion. Are there any questions on Newton's second law of motion? Any questions? Okay, if there are no questions, then we push on to Newton's third law of motion. Now, Newton's third law of motion is very, very important also. Okay? Because it helps us explain why sometimes, despite there being a force, it helps us explain why sometimes you don't see acceleration. Okay? So it says as follows. For each force exerted on one body, so for each force exerted on one body, there is an equal but oppositely directed force on some other body interacting with it. This is often called the law of action and reaction. Notice that the action and reaction forces act on two different interacting bodies. So, if you exert a force on a body, let's say for instance, you try to push a wall because you can push. For example, you can push a door, the door swings, okay? But you try to push against the wall. You will notice that most likely the wall is not going to move. It will stay where it is. So the wall is not accelerating. The velocity of the wall does not change. The reason why the wall does not change is because the wall is also pushing back against you. So the wall will always try to push back against you. So you push against the wall is pushing against you. So at the end of the day, these forces, the wall will always try to generate a force which is equal but opposites. Okay? So when you are pushing against the wall is not happy with what you're doing. So the wall pushes back against you. The same thing is happening where you're seated. Most likely you're seated on a chair. And as we are going to show, you are exerting a force on that particular chair, and the force you're exerting is called weight. The reason why there is weight being exerted on that chair is because you've got mass. And that mass is being pulled by the earth. So you are always constantly being pulled downwards. You're always being pulled down by the earth. And that force with which you're being pulled, that is what is called weight. So that's what you're exerting on that particular chair you're seated on. The chair is not idle. It feels your weight. So the chair is pushing back against you. Okay? However, the chair will always try, depending on how the chair is made, on which you are seated, it will always try to push back against you with an equal but opposite force. But this might not always be the case, because there might be some cases where you sit on a chair and that chair might be, let's take for instance, for a baby. So you as an adult sitting on a chair meant for a baby, that chair would not be able to generate enough force to support your weight. So that chair might break. Okay. So basically this is Newton's third law of motion. The law of action and reaction. If you exert a force on something, that particular something is also going to try to exert an equal and opposite force. Any question on what we have looked at so far before we push forward? Newton's first law of motion explains why an object remains at rest or an object moves with constant velocity. The reason why that happens is because there is no force acting on that particular object. Not just any force. There is no resultant force. So if there is no resultant force acting on a particular object, then that object stays at rest or it moves with constant velocity. Newton's second law of motion explains what's going to happen if there is a resultant force present. If a resultant force is present, that resultant force will cause an acceleration which is proportional to the force but inversely proportional to the mass of the object. F is equals to ma here. And here in equation 2, we show how you are supposed to work out that resultant force. Okay. The next thing is the third law of motion. Here, to say if you exert a force on an object, if you interact with an object by exerting a force on that particular object, that object is going to interact with you by exerting an equal but opposite force. Now let's come to the law of universal gravitation here. So when you have two masses, m1 and m2 here, if you have masses m1 and m2, those masses have an attraction to each other. However, this attraction is only visible if one of the masses is very, very big. For example, you and the earth, or anything and the earth. So in this case, you have mass 1, maybe an object which is on earth. It might be a computer, it might be a person, and mass 2 might be the earth, like this. So if you have got mass 1 and mass 2, the force of attraction between these two particular objects, which is what's given here, Fg, the force of gravity, is equals to G, the gravitational constant, multiplied by mass m1 and m2, then divided by the radius, which is the distance between the centers of these two objects. So the r is the distance from the center of the objects of mass 1 to the center of the other object. So in the case of a person who is on earth, we can say, okay, that particular person is m1, then the mass of the earth is m2, then in this case r is the radius of the earth, and of course this g is the constant. G is equals to 6.67 times 10 to the power minus 11. So when we do this, so if you make m1, so okay, fine, here we're saying m1 to be the mass of the earth, then in that case the mass of the earth is this one. Our planet has got this much mass, 5.97219 times 10 to the power minus 24. And we let m2 be the mass of an object on the surface of the earth. So we just denote that as m. Then the distance between the object on the surface of the earth and the center of the earth, we call that r, which is the radius of the earth. So in this case, RE is going to be, it's 6,371,000 meters. So in this case, you can write this equation. Fg is equals to G m1 m2 r. You can write it as Fg is equals to G. Then m is the mass of an object on the surface of the earth. Then me is the mass of the earth. Then re is the radius of the earth squared. Now the mass of the earth, the g and the radius of the earth, these are not going to change. These are constants. The object on the surface of the earth can change to be something else. So m can change, but these other things are constants. So we group the constants together, so we end up with g, then multiplied by me, then re squared. So we have this thing in the brackets. So when you work out this thing in the brackets, it's supposed to come out a constant. When you work out this thing, so small g is equal to capital G, then me, then divided by that. So we put in these numbers. So the capital G is 6.67 times 10 to the power minus 11. Then the mass of the earth is what you have here, then divided by the radius of the earth squared. When you work out this calculation, what you end up with is this. G is approximately 9.81 meters per second squared. So actually the capital G, the mass of the earth, then the radius squared, gives you your acceleration due to gravity. We have used this quantity before. So with this G, acceleration due to gravity, multiplied by the mass, what you get is mg. This mg is the force of gravity on an object of mass m. Are we clear? Are we clear? The force of gravity is given by the mass of the object on the surface of the earth multiplied by the acceleration due to gravity. That's how you work out the force of gravity. That's why things fall. That's why mangoes fall, apples fall. If you are in a bar, then you doze a bit, you find your bottle has fallen. Okay. The reason is because that particular thing which is falling has got mass. If you are drunk, then you trip, you're going to fall because you've got mass and the earth is always pulling on you. Are we clear? Are we clear on this? This force of gravity? Okay, I didn't hear anything, so I'll move forward. Okay, so as long as you've got mass, okay, as long as an object has got mass, there's one type of force which acts on such an object. That's called the force of gravity. The force of gravity is what is commonly called the weight of an object. This force of gravity, Fg, is equal to the mass of the object, the mass on the surface of the object, multiplied by the acceleration due to gravity. As long as an object has mass, and this object is on Earth, then it's going to experience a force of attraction. In this case, the Earth is acting as a magnet, attracting you so that you come down. Are we clear?
The mass of the Earth, are we given in the question papers as in the exam?
No, we have just shown that we don't actually, information about the mass of the Earth, this mass of, you can find it on Google. The mass of the Earth, I got it from Google. The radius of the Earth, I got it from Google. Then this G, capital G, I also got it from Google. Then you work out this thing, then you find your small g is equal to 9.8 meters per second. So every time you're using this, 9.8 meters per second squared as your acceleration, this 9.8 meters per second squared has information about the mass of the Earth and the radius of the Earth. So your acceleration g equal to 9.8 meters per second squared depends on which planet you're on. On Earth, it is 9.8 meters per second. If you go somewhere else, if we ever go somewhere else, for example, people are trying to get to Mars, the acceleration due to gravity there is different because Mars has got a different mass and it has got a different radius. So if you plug in these things there, you get a different acceleration due to gravity on Mars compared to Earth. Any other question? Okay. Next, we'll move on to types of forces which act on objects. The first obvious type of force, of course, is the weight, because this object is on the surface of the Earth, so it feels the attraction of the Earth. Any object of mass m on the surface of the Earth experiences a pull of gravity, which is what is called weight. This weight, as we have shown, is equal to Fg, force of gravity is equal to the mass multiplied by acceleration due to gravity. The weight, denoted Fw, is just the mass multiplied by the acceleration due to gravity. You are being pulled down. So this is how you get the size of the weight. Fw is equal to mass times g. That's how you get the size of the weight. Weight is a force. So a force is a vector. It has got size, it has got direction. In the case of weight, the weight is always towards the center of the Earth. Always. When an object falls, it falls down. There is no case where you have got an object falling up. No, you always fall down. Okay? So the weight of an object always points down. So that's the first thing. First type of force, weight. As long as you have got mass, you have weight. Your weight is equal to the mass times g. The g is acceleration due to gravity. The mass is the mass of the object. The next type of force is what is called the normal force. Now, the normal force comes about because of Newton's third law of motion. For example, this box which I have here, this box is on a floor or on a table, whatever it is, but it is on a surface. So this box has got mass. Because this box has got mass, this box is being pulled by the earth downwards. So this box has got weight associated with it. It is exerting a weight on this floor. Now, this floor feels the weight of this box, and the floor will not be happy about this. So, according to Newton's third law of motion, the floor is going to exert an equal but opposite force, which is what is called the normal force here. The normal force is the equal but opposite force associated with the weight of an object on a surface. That's why you are able to sit on your chair. You are exerting a weight on that chair. That chair, I can assure you, is not happy about what you have done, so it is pushing back. However, the chair is not going to overreact. It's going to push back with an equal and opposite force. So this normal force is always equal. It's not always equal. The surface tries to generate a normal force which will be equal to the weight. However, there are cases where your chair tries to generate a normal force equal to the weight, but it fails. For example, if someone is obese, then you sit on a particular chair, then that chair will try to support you, but eventually, because your weight is too much, the chair will not be able to generate enough force to support your weight. So in that case, the chair fails to generate a normal force equal to your weight, and that chair will break. Okay, so two forces. There is the weight. The weight is obvious because any object has got mass. So because of the mass, there is weight associated with that particular object. These objects usually, they are not in the air. They are either on a table or on the floor. So this floor or table is not going to be happy about this particular object you have put there. So it will try to generate a force which is equal and opposite to the weight. And that was what you're calling the normal force. The normal force is always equal and opposite the weight, so that that particular object can be supported. Okay? Then there is also a force called tensile force. Now, tensile force is the force which you find in a string or in a rope. So you might tie this box with a rope, then you pull it. As you are pulling the rope, there is a force in that rope. The force which is in that rope, that is what is called the tensile force. Okay. As this box is trying to move, there will be another force which is trying to oppose the motion of this box. This other force which will be opposing the motion of this box, that is what is known as friction force. The friction force always opposes the motion of an object. So, for a simple case like this one, where you have a mass sitting innocently on the floor, this mass has got a weight associated with it, which is Fw, pointing down. The floor is not happy that this box is seated on it, so the floor is going to push back against the box, which is the Fn. If you are trying to push this box or pull this box, this is the force you have here, F. As the box is being moved along the floor, there's going to be a force called friction which would try to oppose the motion of this box. Are we clear? There will be a force called friction which would try to oppose the motion of this box. Friction always opposes the motion of objects. So in this case, you actually have four forces, four different types of forces acting on this particular box. Each of these forces is not a resultant. For you to get a resultant, you need to add the forces acting along the x-axis, which is in the horizontal direction, which is this force and this force. You need to add the F and the FF here, the friction force. If you add them, then you get a resultant force along the x-axis. Along the y-axis, there is a weight and the normal force. If you add the weight and the normal force, then you get the resultant force acting along the y-axis. For you to get the resultant force also, you need to choose direction. You can choose the direction in which the box is moving to be positive. So this direction, if the box is going to move this direction, so you choose this to be positive force. So this force is going to be positive. It means that this friction force is going to be negative. So you end up with F minus Fn as your resultant force. In this particular case, the normal force is pointing up here along the y direction, the positive y, so you can choose that to be positive. If you do that, then the Fn is your positive force, then the weight is going to be negative. It's up to you what you want to do, basically. When it comes to vectors, we give you a choice. Okay. You can also have an arrangement like this where the mass is not on a surface, but it's hanging from a rope. It's being supported by a rope. So this particular mass, as you can see, has got the weight Fw, which is pointing down. However, there is also, it's being pulled up. That's why it's not moving. Okay? Otherwise, if there was no rope, this weight would cause this mass to move down with increased velocity. But the fact that this thing is not happening means that there is another force in this rope which is undoing the effects of the weight. And this is what you call the tensile force, tension. Okay? Tensile force is a force which lives in ropes or cables. Okay, in the case of friction force, we'll talk about a bit of friction. It opposes the motion of an object, but the friction force also depends on something called coefficient of friction. Now, there are two types of frictions. It depends on whether the object is at rest or the object is moving with constant velocity. If the object is at rest, then the kind of friction acting on that particular object is something called static friction. If the object is moving with constant velocity, then the friction acting on that particular object is what's called kinetic friction. The object can be moving with constant velocity or the object can be accelerating, but as long as the object is moving, the friction associated with that particular object is called kinetic friction. So there are two types of friction. Friction associated with an object which is at rest, that's called static friction, and friction associated with an object which is in motion, that's what's called kinetic friction. Now, static friction and kinetic friction are related to the normal force, which in turn is related to the weight of the object, because the normal force usually is equal to the weight of an object. So there is a connection between friction, the normal force, and the weight. And the connection is this, something called the coefficient of friction. The coefficient of friction is equals to the friction force divided by the normal force. So since there are two types of friction, there are also two types of coefficients. There is something called the coefficient of static friction. It's just a number. Coefficient of static friction is equal to the static friction divided by the normal force. So coefficient, that's how we write it. Coefficient of static friction, mu s, is equal to the static friction divided by the normal force. Static friction is basically maximum friction. So in this case, if you are looking for the static friction, that's going to be equal to the coefficient of static friction multiplied by the normal force. So this is how you get your friction force. When an object is at rest, friction force is equal to coefficient of static friction times normal force. If the object is in motion, it's moving, then the coefficient of friction is what is called coefficient of kinetic friction. This coefficient of kinetic friction is equal to the kinetic friction, which is the friction which an object in motion has, divided by the normal force. Here, mu k, coefficient of kinetic friction equals to friction force divided by normal force. The kinetic friction force is equal to the coefficient of kinetic friction times the normal force. So here, mu f is equal to mu k multiplied by normal force. So our two types of friction, kinetic friction force and static friction force, they all depend on normal force. So here there's normal force, here there's normal force. The only difference is this quantity here, the coefficient of static friction and the coefficient of kinetic friction. That's the only difference. So whenever you're working out friction, for you to find the friction acting on a particular body, opposing the motion of a body, you need to multiply the coefficient of friction times the normal force. So you need to ask yourself, is this object at rest? If the object is at rest, then the friction, the coefficient you're looking for is the coefficient of static friction. If the object is in motion, then the coefficient you're looking for is the coefficient of kinetic friction. Are we clear? This is how you find friction. It's a very important force. It's going to come up a lot. This force, the force which opposes the motion of an object. Whenever there is motion, whether the object is in motion or it's not moving, friction is always present. Are we clear? Are there any questions? We have come to the end. We have run out of time, so we'll continue this discussion tomorrow, where we're going to look at how do you calculate the resultant force. So unless there are any questions, we are going to end here. So I'll stop sharing my screen, then finish the recording.